Hi everyone, this is Nihar sir. So today in the subject of strength of material, we will study a new chapter, your bending moment and shear force. This is your totally new topic, bending moment and shear force. Previously you have not studied these things. So today you will study what is a bending moment and what is a shear force. So you have seen in the building the beam column. The vertical part is your column, and above these two vertical part column there will be one beam is there. So in this beam, what will happen? Force will be applied horizontally, vertically. That means above this beam there will be roof of 5 mm or 10 mm. So this will apply force on the beam. So due to the application of force, where the force applied and where the beam bends, we will study scientifically. So this is all about shear force and bending moment. So first thing we will study what? Beam. So right, what is a beam? What is a beam? Beam is a structural member which is acted upon by a system of external loads right angle to its axis. That means you have seen in a building there will be beam. In this beam, this is a horizontal member, structural member, and force is acted perpendicularly. That means this is the axis of beam and force applied vertically, right, perpendicular to the beam. So a beam is a structural member which is acted upon by a system of external forces. That means more than one external forces acted on this beam which is right angle to its axis. This is the axis of the beam, this is the axis of the external forces. So these are right angles, means perpendicular, 90 degree. So right, what is a beam? A beam is a structural member which is acted upon by a system of external loads. A beam is a structural member which is acted upon by a system of external loads, right angles to its axis. That means force, the external force is right angle to the axis of the beam. So next part, what is bending? First we will study what is beam. Next we will study what is bending. Bending means bend. So bending implies the deformation of a bar produced by the loads which is perpendicular to its axis, as well as the force couple acting in a place passing through the axis of the bar. That means bending is what? The load applied on the beam. So due to the application of the load, the deformation or deflection causes in a beam is known as bending. So right, bending implies the deformation of bar. Bending implies the deformation of bar produced by loads perpendicular to its axis or right angle to its axis, as well as force couple couple means two equal and opposite force, that is called couple, as well as force couple acting in a place passing through That means bending occurs in a beam due to the perpendicular force, or you can say the couple. That means one at the below and one at the above. Two loads of equal quantity, opposite direction, you can say couple. It may be a perpendicular force, or you can say couple. Due to the perpendicular force, or you can say couple, bending occurs in a beam. So this is beam and this is bending. Next, we have already seen that whenever a horizontal beam is acted upon by a vertical set of loads, the beam becomes bends, or you can say deflects due to this load. So the amount of bending the beam occurs, the amount of bending in a beam occurs depends upon the amount of load, the types of load, the length of the beam, the types of the beam, or the elasticity of the beam. So these are the factors which depends on the amount of bend. The beam bends, how much the beam bends, it will depends upon the amount of load, how much load it will occur on the beam, types of load, which types of load acting on the beam, length of the beam, how much the length of the beam, types of beam, different types of beams are there, we will study further. Next, the elasticity of the beam, how much elasticity a beam has. Then lastly, the scientific way of studying the deflection or any other effect by drawing, or you can say analyzing, by drawing, or you can say analyzing the shear force or bending moment diagram of a beam. This is used, or shear force bending moment diagram is used to study scientifically the deflection of a beam. So right, we have already seen that whenever a horizontal beam is subjected to loads, the beam bend or deflects. The beam bends or deflects. The amount of bend depends upon the amount of bends depends upon the amount of load, types of load, amount of load, types of load, length of beam, types of beam, and elasticity of the beam. Next, to study scientifically the deflection or any other effect, by drawing or analyzing the shear force or bending moment diagram, bending moment diagram of the beam. So why we need the shear force or bending moment diagram? The shear force or bending moment diagram we should need to scientifically study the deflection of the beam. Scientifically, where the deflection will occur, how much load will be applied, where the maximum load will be applied, where the maximum bending will be occur. So these things we should know from the shear force or bending moment diagram. The next we will study the types of beam. Types of beam. So generally beams are of 5 types. What are the? Cantilever beam, simply supported beam, overhanging beam, fixed beam, and the last one is continuous beam. So 5 types of beams are there. So right, types of beam. Types of beam. So right, the following are the 5 types of beam. What are those? A. Cantilever beam. First one is your cantilever beam. What is a cantilever beam? A cantilever beam is one whose one end is fixed and other end is free. You have seen your home, at the front there will be your chaja. In the chaja, the beam will overhang from the wall. So one end is fixed, other end is free. If one end is fixed, other end is free, that you can say cantilever beam. So the figure of cantilever beam is like that. Let it is a beam. A, your B, your load will be applied. Your load W is applied, and the total length is small l. This is your span length. Span length is small l. So a cantilever beam is one whose one end is fixed and other end is free. A beam whose one end is fixed and other end is free is known as cantilever beam. Is known as cantilever beam. You have already seen the cantilever beam examples in your home. Cantilever beam. Then the next, second one is your simply supported beam. Simply supported beam means you have seen in your home, at your room, the one beam is there. At the two sides of the beam, there will be two supports. This is two support of the column. This is two column. If one beam is there, that is called simply supported beams. That means a beam whose two ends are supported by two supporters at the two ends, and the two supporters are reaction force are always upward. So what is a simply supported beam? See a figure of simply supported beam. If it is a beam, then there will be two supports, two columns. A, B. Load will be applied here, W, the point C. So these are two supporters and load applied. This is the beam. This figure is known as, in this shape of a beam is your simply supported beam. Simply supported beam. Simply supported beam means beam whose two ends are freely rest on two supporters, whose two ends are two supporters. A beam whose two ends are freely rest on two supporters is known as simply supported beam. Simply supported beam. And these two supporters are acting upward. These two supporters are acting upward. Here see the two supporters acting upward. So if a beam has two supporters at the two ends, then you can say simply supported beam. After that, the third type of beam is your C, overhanging beam. Overhanging beam. Overhanging beam means which will be hanged over the beam supporters. That means a beam whose two ends are not supported by the supporters such that hanged out, or you can say projected beyond the support. If support is there, if it will be projected beyond the support, then you can say overhanging beam. So see the figure, overhanging beam. Here is the beam. There is one supporter at one end, another supporter is here. A, B, C. Load will be applied here. So this is overhanging beam. This projected part is there beyond the support. So like in case of overhanging beam, both the ends are not supported by the support such that projected beyond the support. So projected beyond the support, that means overhanging beam. Then the fourth one is your fixed beam. Fixed beam. The name fixed signifies the two ends of the beam is rigidly fixed. That means when the two ends of the beam is rigidly fixed or built into the supporting wall, or you can say column, we can say it is a fixed beam. That means beam two ends are fixed. So diagram of the fixed beam here you will see. This is the beam, load will be applied here, and this is the two fixed bar. Two ends of the beam will be fixed. A, B, C. This is the examples of fixed beam. In fixed beam, the two ends of beam are rigidly fixed or built in into the supporting, into the supporting wall, or you can say column. It will be fixed to the two ends by the supporting wall, or you can say column. The last one of the beam is your continuous beam. Continuous beam. Continuous beam we have all of you have seen. Continuous beam is where in case of railway bridge, you can say railway bridge or road bridge, you will find above the bridge below number of pillars are there. So if a column has if a beam has more than two supporters, then you can say it is a continuous beam. If a beam has more than two supports, you can say continuous beam. So the figure of continuous beam is here, you can find. See here. This is the beam. Have one support, here another support, here another, and here another. A, B, C, D, E. Then more than two supports, if a beam has, then you can say continuous beam. So a continuous beam is one in which more than two supports are there. If a beam has more than two supports, we can say it is a continuous beam. So there will be five beams. First one is cantilever beam, second one is your simply supported beam, third one is overhanging beam, fourth one is fixed beam, and the last one is your continuous beam. We have studied the 5 types of beam. Now we will study types of loads. Types of loads. Types of loads. According to the beam subjected to 3 types of load. First one is your concentrated load, you can say point load. Second one is a uniformly distributed load. Third one is uniformly varying load. So the beam is subjected to 3 types of load. Right? The beam is subjected to either of the following 3 types of load. Either of the following 3 types of load. The first one is your concentrated or point load. Concentrated or can say point load. That means the load is concentrated or it will be acting a single point. So see the examples. If it is a beam, let it is a simply supported beam. If load is applied at a single point, then you can say simply concentrated load or you can say point load. If a load is applied at a single point, then you can say it is a point load or concentrated load. Next, the second one is your uniformly distributed load. So the second one is your uniformly distributed load or you can say UDL. So what uniformly distributed? See the figure. If it is a beam, simply supported beam, load. Or here simply supported beam. Here the load is uniform distributed along the beam. Here is also load is uniform distributed along the beam. So here the load is load W per unit length, or you can say your load is W per meter. Then the third one load is your uniformly varying, VARYING, uniformly varying load, or you can say UVL. Third one is your uniformly varying load. What is a uniformly varying load? Uniformly varying, that means uniformly increase, uniformly decrease, or uniformly increase to that some point, then again decrease. So here you will see the figure. It is uniformly what? Increase. Uniformly increase. And again one figure you see. Here uniformly decrease. Again another figure you will see where electric beam, here it is first uniformly increase, then uniformly decrease. So here the load is W per meter, here also load is W per meter, here also load is W per meter. So here the three figures are uniformly varying load. So three types of load: concentrated load or point load here, then uniformly distributed load, load distributed uniformly along the beam, that is uniform distributed load. Uniformly varying load means the load is varying according to the length. It may be increased, it may be decreased, or sometimes up to some extent it will increase, and after that it will also decrease. These are the three types of loads. Next we will study shear force and bending moment. What is shear force? What is bending moment? First write shear force. Shear force, shortly you can write SF. Shear force. The shear force at the cross section of a beam is defined as the unbalanced vertical force to the left or right of the section. We can, what I will say, unbalanced vertical force. Vertical force applied across the beam. So the unbalanced vertical force to the left and right of the section, we can say shear force. It is abbreviated as SF. Then your bending moment. The bending moment at the cross section of a beam is defined as the algebraic sum of moments of the forces to the left or right of the section. Similarly, the shear force bending moment is the algebraic sum of moments of forces to the left hand side or the right hand side of the section, and bending moment is abbreviated as BM. So what is shear force? The shear force at the cross section of the beam. The shear force at the cross section of the beam is defined as the unbalanced vertical force to the right or left side of the section. The unbalanced vertical force to the right or left side of the section, you can say shear force. Full stop. It is abbreviated as SF. Somewhere it is written as SF. That means shear force. It is abbreviated as SF. That means shear force. After that, bending moment. Bending moment you can say beam. So what is beam? Bending moment is defined as bending moment in the cross section of a beam is defined as the algebraic sum of moments of the force to the left hand side or the right hand side of the section. So right, first point, bending moment at the cross section of a beam is defined as the algebraic sum of moments of the force to the right or left side of the section. And the bending moment is abbreviated as Vm. It is abbreviated as Bm. So bending moment in short we can write Bm. This is the shear force and bending moment. When we will do some problems, you will clearly know what is bending moment and what is shear force. Now, the sign convention for shear force and bending moment. Sign convention for shear force and bending moment. During the calculation, we have to know the sign of how we take shear force as positive or negative and how we take bending moment as positive or negative. So right, first one is your shear force. First one is your shear force. See, there will be two figures here. Right, I will show you. Here is your beam. Here one axis XX. Here the left hand side upward. Here the right hand side downward. This is figure A. This is figure A, or you can say positive shear force. Positive shear force. If the beam is like that, if this is the axis XX, then this is the left hand side of the beam downward, then the right hand side of the beam upward. This is figure B, or you can say negative shear force. Negative shear force. So here positive, here negative. So when we will take positive shear force, when we will take negative shear force. So we take shear force as positive when the left hand side of the beam tends to slide upward and right hand side of the beam tends to slide downward, as shown in figure A. So when we will take shear force as positive, if the left hand side of the beam tends to slide upward and the right hand side of the beam tends to slide downward. Similarly, we take shear force as negative when the left hand side of the beam tends to slide downward and the right hand side of the beam tends to slide upward. During the calculation, we will detail study this shear force positive and negative. So right, we take shear force as positive. First point, we take shear force as positive when the left hand portion tends to slide upward, left hand portion tends to slide upward, or the right hand portion tends to slide down. We take shear force as positive when the left hand portion tends to slide upward and the right hand portion tends to slide downward, as shown in figure A. So next point, shear force negative. Similarly, we take shear force as negative. Similarly, we take shear force as negative when the left hand portion tends to slide downward, or right hand portion tends to slide upward, or right hand portion tends to slide upward, as shown in figure B. So in the figure A, we have seen positive shear force when the left hand portion tends to slide upward, right hand portion tends to slide downward. In the figure B, we have seen negative shear force when the left hand portion tends to slide downward and the right hand portion tends to slide upward. Previously we see positive shear force, negative shear force. Now we will see positive bending moment, negative bending moment. So the next point number 2 is your bending moment. Point number 2 is your bending moment. So for bending moment we will two figure, positive bending moment and negative bending moment. That is your figure C, or you can say positive bending moment, or you can say sagging, S-A-G-G-I-N-G, sagging moment. This is. Then another one is your negative. This is figure B. That is your negative bending moment, or you can say H-O-G-G-I-N-G, sagging your positive, negative. So what is it? We take bending moment as positive if it tends to bend the beam causing concavity upward. This is the concavity. Concavity upward means positive and convexity upward means negative. Right? We take bending moment as positive if it tends to bend the beam causing concavity upward. causing concavity upward as shown in figure C, as shown in figure C, and is also called sagging moment. SAGGING, sagging moment. Then another is your hogging moment or negative shear for bending moment. So similarly we take bending moment as negative. Similarly, we take bending moment as negative if it tends to bend the beam, causing convexity upward, as shown in figure D. As shown in figure D is as shown in figure D, and is also known as hogging moment. That means when the beam bends upward, that means concavity upward will happen, then you can say positive bending moment or sagging moment. If the beam bends downward, that is convexity upward, then you can say negative bending moment or sagging moment. Next we will study the relation between loading, shear force and bending moment. So give heading. Relation between loading, shear force and bending moment. So what is the relation between loading, shear force and bending moment? That means under which load the beam condition is what? That means after the application of three different load we have previously discussed: point load, uniformly distributed load, uniformly varying. Under these three load, what are the effects of the beam? We will see here. So there will be 4 points. The relation between loading, shear force and bending moment, it will have 4 points. What are those? The first one is, if there is a point load at the section on the beam, then the shear force changes suddenly. That is, the shear force line is vertical, but the bending moment line remains same. That means whenever a point load is applied on a beam, in that case the shear force changes vertically, but the bending moment does not change. Second point, if there is no load, means no load, if there is no load between 2 points, then the shear force does not changes. That is, the shear force line is horizontal line, but the bending moment changes linearly. That is, the bending moment line is an inclined straight line. Next, third point. If there is an uniformly distributed load between 2 points, then the shear force changes linearly. That means the shear force line will be an inclined straight line. But the bending moment changes according to parabolic law. That is, the bending moment line is an parabolic curve. Then fourth one, the last one, if there is an uniformly varying load between 2 points, then the shear force changes according to parabolic curve, or you can say the shear force line is a parabolic curve, but the bending moment changes according to cubic law. That is, the bending moment line will be an cubic curve. So there will be 4 points. First, in case of point load, second in case of non-load, third in case of uniformly distributed load, and the fourth one is in case of uniformly varying load. Let's write. First, if there is a point load at the section of a beam, at the section on a beam, then the shear force SF, then the shear force changes suddenly. Then the shear force changes suddenly. Bracket, that is, the shear force line will be vertical. Shear force line will be vertical. But the bending moment, or you can say BM, the bending moment, you can say BM line remains same. So what will happen if there is a point load at the section on a beam, then the shear force line changes to vertical position. That means always the shear force changes vertically, but the bending moment line remains same. That means previously bending moment line is, after that also bending moment line is same. That means due to the point load, there will be no changes in bending moment line, but the shear force line is vertical, suddenly changes to vertical. Then the second point, after the point load, but we will say there is no load. That means if there is no load, between 2 points, if there is no load between 2 points, then the shear force, SF means shear force, then the shear force does not change. Shear force does not change. That means, that is, the shear force line, that is the shear force line will horizontal. The shear force line will be horizontal, but the bending moment, or we can say BM, the bending moment changes. The bending moment changes linearly. The bending moment changes linearly. That is, the bending moment line will be inclined. The bending moment line will be inclined straight line. The bending moment line will be inclined straight line. So in the no load condition, if there is no load between 2 points, then the shear force does not change, but the bending moment changes linearly. So what will changes when we will solve many problems? We will see what will happen. So the second point, next third point. What will be the third point? UDI. So if there is an uniformly distributed load, or you can say UDI, bracket right, uniformly distributed load. If there is an UDL between 2 points, if there is a UDL between 2 points, then the shear force changes. The shear force changes linearly. The shear force changes linearly. In the bracket write that is I dot E dot. That is the shear force line. The shear force line will be an inclined straight line. Inclined straight line, but the bending moment changes. But the bending moment changes according to parabolic law. In bracket write I dot E dot. That is the bending moment line will be parabolic chord. That means if there is a uniformly distributed load or UDL between 2 points, in between 2 points if there is UDL is there, then the shear force changes linearly. Linearly inclined straight line. It is horizontal. This is inclined. This is inclined. So the shear force line is an inclined straight line, but the bending moment changes according to parabolic chord. According to the parabolic chord. So these are the 3 points. Next point 4. Next 4 points. If there is an uniformly varying load between 2 points, in between 2 points, if there is a uniformly varying load, then the shear force changes according to parabolic law. That is, the shear force line will be in parabolic chord, but the bending moment line changes according to cubic law, or the bending moment line will be in cubic chord. The 4th point, if there is an uniformly varying load, or you can say UVL, if there is a UVL between 2 points, then what will happen? Then shear force changes according to parabolic law. That is, I got you. That is, the shear force line will be parabolic chord. Shear force line will be parabolic chord. But the bending moment changes. According to cubic law. That is, the bending moment line will be cubic chord. That means in case of UPL, shear force will be parabolic chord and bending moment will be cubic chord. You will see when in case of point load, the shear force changes vertical, the bending moment constant. In case of no load conditions, the shear force is constant horizontal, the bending moment is inclined. In case of uniform distributed load, the shear force is inclined, bending moment is parabolic curve. In case of uniform varying load, the shear force is parabolic curve, bending moment is cubic curve. So what are these? When we will solve problems, you will details know about that. So don't worry about this. Next, we will study. We have studied different beams: cantilever, simply supported, overhanging, fixed, continuous. So different examples on cantilever beam. That means point load applied on a cantilever beam, or UDL applied on cantilever beam, UVL applied on cantilever beam. See, similarly, different beams and different load we will study in the